Hi students, today we are going to see how to attain MCQ type of questions for review of signals and systems. So all these questions is based upon your gate questions here. Uh, in review of signals and systems, two topics uh, carries a weightage here. One is your classifications of systems, other one is your classification of signals. So classification of systems, you have 5 different classifications: static and dynamic, causal, non-causal, time invariant and variant, linear, non-linear, and stable, unstable. So in this five classification, the first three classification, by seeing the systems, you'll be able to say uh, categorize this classification here without solving the procedures here. But linear and non-linear, stable and stable, we have to solve by the procedure, and then we have to find the value here. Static and dynamic, if your output depends upon your present input, it is said to be static. If it depends upon either past or future, it is said to be dynamic. Right? For example, y of n is equal to x of n. It is static. So if y of n is equal to x of n plus 1, future, or x of n minus 7, past, so then it is said to be dynamic. And similarly for causal, non-causal, if your output depends upon present and past, it is said to be causal. Future, if any one sample depends upon future, it is said to be non-causal. Similarly, time invariant and variant, if your input is multiplied by the time period, any variant of time period such as n, n square, n minus 1, n plus 1, so any variant of your time period, then it is said to be time variant. Else, it is said to be time invariant. So by seeing the system, we'll be able to identify. Then classification of signals. So you have three major classification. One is your energy and power signal. So energy signal, the signal is said to be energy signal if your value of E is finite. So and P, power, is going to be 0. So this condition you have to keep it in mind. If a signal is said to be energy signal, your energy E will be finite, your power P will be 0. And for power signal, your P will be finite, E will be infinite. Okay, E will be infinite. So the energy signal E is given by limit n tends to infinity, summation minus infinity to plus infinity, or minus n to plus n, modulus of x of n whole square. And the power P is given by same similar to your E, except this it should be multiplied by 1 divided by n minus 2 into n plus 1. So the maximum formula we'll be using for this two is summation n equal to 0 to infinity a power n equal to 1 by 1 minus a. And other one is summation n equal to minus infinity plus infinity. Here it will be using your x of n square. Next is classification is odd and even signal. So odd and even signal, or symmetry, anti-symmetry signal. So here a signal x of n is said to be symmetry or even signal if x of minus n is equal to x of n for all values of n. If it is x of minus n is equal to minus of x of n, it is said to be odd signal or antisymmetric signal. So they might ask you to find whether it is even or odd signal, or find the even signal or odd signal values here, right? So if you want to find the even signal value, the formula is 1 by 2 of x of n plus x of minus n. So if x of n, they have given it as 2 to 4 time period here, then x of minus n will be minus 4 to plus 2. So it will be reverse of it, right? And after calculating this reverse, and the summation of these two things will be divided by 2 to get your even signal. And for odd signal, 1 by 2 x of n minus of x of n minus 1. And the third one is going to be periodic and aperiodic signal. So here we'll be calculating the periodicity, that is fundamental period, right? So periodicity or fundamental period. And then if your n value fundamental period is said to be an integer, it is said to be periodic. If it is not an integer, it is said to be an aperiodic signal. So we'll have some 4-5 gate questions here. A system with an input x of n and y of n, output y of n, is described by the relation y of n equal to n into x of n. So this system is the option, or linear and time invariant, linear and time variant, non-linear and time invariant, and non-linear and time variant. So here they have concentrated mainly on two classification. One is its linearity, other one is going to be time invariant or variant. So as I said earlier, by seeing the system, we can say whether it is time variant or invariant. Here, the input is multiplied by the time period. So if the input is multiplied by the time variant, it is said to be time variant. Okay. So time period or any variant of time period, instead of n, it is if it is n minus 1 or n plus 1 or n square, whatever it may be. So if it is multiplied by the time period, it is said to be time variant. So here either it may be option B or option D. Now we have to find about the linearity. So for linearity, you have to go for three steps here. First, you have to get your two samples of your input, x1 of n and x2 of n. So your y1 of n is nothing but n times of your input. Your output is nothing but n times of your input as per the statement. The linear combination of your output signals will be A into y1 of n plus B into y2 of n is equal to A into n into x1 of n. Replace your y1 of n and replace your y2 of n as n into x2 of n. So I can get it as A into n into x1 of n plus B into n into x2 of n. Next step is to calculate the linear combination of your input signals. Here, you should be very careful here, right? So always keep it in mind. Your output is equal to, you just framed your statement in terms of your words. Here, output is n times of your input. So here, input is going to be linear combination of your inputs, x1 of n and x2 of n. So for all the problems, your x3 of n will be equal to a into x1 of n plus b into x2 of n. Now we have to find the output. So this place, you have to check with your statement. So statement, as per the statement, your output is n times of your input. So replace your x3 of n as a into x1 of n plus b into x2 of n. So finally, I got the output of the linear combination of input signal. Now I have to verify the linear combination of output signal is equal to the linear combination of your input signal. If it is equal, then the system is said to be linear. So the option is B, linear and time variant. Next is the input and output of a CT system are respectively denoted by x of t and y of t. Which of the following description corresponds to the causal system? So causal system means you have to keep it in mind. The output depends upon the past and present input. So it is said to be causal. Even if one sample depends upon future, it is said to be non-causal. So we can see the options here. So option A, B, C and D. So here in this option, x of t plus minus 2, it's past, x of t plus 4, it's future. So it's not a causal. T minus 4, we are not going to bother about this one. Only the input function we are going to bother. So x of t plus 1, it's future. So it's not a causal. Here t minus 4, we are not bothered. Input function x of t minus 1. So it depends upon past. So it may be your causal. Option C. Next we can see your option D also. So t plus 5, we are not going to bother about this term. So only we are going to bother about the input term. So x of t plus 5, so it depends upon the future. So the one and only option is option C, y of t equal to t minus 4, x of t minus 1. So next, a discrete time signal x of n is equal to sine pi square n, where n is nothing but an integer, right? So here they have given an option, four option as periodic with period pi, periodic with period pi square, periodic with period pi by 2 and not periodic. So here they ask you to find whether the signal is periodic or aperiodic. If it is periodic, what is the periodicity? If it is aperiodic, we are not going to bother about the periodicity, right? So for this one, we have to find the fundamental period. So how to find the fundamental period? So here they have given your x of n as sine pi square n. So in the trigonometric function, you know it very well. How will we be mentioning our trigonometric function? Sine omega naught n or cos omega naught n or tan omega naught n. So if it's so, what's your omega naught here? Pi square. So the fundamental period is nothing but 2 pi by omega naught into m. So this is your formula where m is nothing but the smallest integer which we use to convert this 2 pi by omega naught into an integer value here. Right, so here replace your omega naught as pi square. So 2 pi by pi square, this pi and pi get cancels here. So 2 pi by m. So in this one, even if here the m should be an integer, right? So here in the denominator, it is pi here. So pi is not an integer. So your fundamental period is not an integer value. So since it is not an integer value, it is said to be aperiodic or not periodic. So since it is aperiodic, we are not going to bother about the periodicity too. So we are going to choose the option D. Next, one more question. So let h of t be the impulse response of a linear time invariant system. Then the response of the system for any input u of t. Here they have given your h of t as impulse response. Input x of t is nothing but your u of t. That is your unit step function. So what is unit step function? The t value will be 1 for t greater than or equal to 0. For less than 0, it is said to be value is 0 here, right? So they ask you to find the response. So response is nothing but y of t. Okay, so they have given the 4 option here, right? So how to find this one? Here you know it very well. The response of the system y of t is nothing but u of t convolution h of t. So this is the formula here, right? That is your input x of t convolution h of t. Here the x of t is given as u of t. So u of t convolution h of t. So here as per the formula, since it is a CT system, so integration minus infinity to plus infinity h of tau u of t minus tau into d tau. So you can use the formula as u of tau into h of t minus tau into d tau. Both the formula is right, but in the option which they have given, x of tau into u of t minus 2. So I have took this formula and you know it very well. Your u of t is nothing but your unit step function. So for t less than 0, the value will be 0. So this infinity minus infinity plus infinity can be changed as 0 to t. Right? H of tau u of t minus tau into d tau. So they have given it is in the option as option A. So your option A is equal to integral 0 to t h of tau u of t minus tau into d tau. So here there is no space or no room for this integrate differentiation and integration here. Right? So probably it will be of A or D, but here there is no square also. So it's going to be option A. We can have one more problem too. So here the impulse response h of n of a linear time invariant system is given by h of n is equal to u of n plus 3 plus u of n minus 2 into u of n minus 7, where u of n is the unit step sequence here. So the above system is stable but not causal, stable and causal, causal but unstable, unstable and not causal. So here they have concentrated two proper classification. One is stability, other one is causality. So as I told earlier, by seeing the function itself, we'll be able to say it's about a causal or non-causal. So if your samples, if your input depends upon present and past, it is causal. If one sample, even one sample depends upon future, it is said to be non-causal. So here in this one, you just check each and every term. You have 3 terms, u of n plus 3, u of n minus 2, u of n minus 7. So this n plus 3 future, n minus 2 past, n minus 7 past. So one sample depends upon future. So naturally it will be not causal. So either option A or option D. So now we have to check your stability. So stability, bistable, bounded input, bounded output. Stability, if you have a bounded input, that is, if your input is bounded input, definitely your output should also be a bounded output. So your impulse response should be finite for stable system. So they have given your h of n. So u of n is your unit step sequence here, right? So if I apply the formula, summation minus infinity to plus infinity h of n is equal to, here it is u of n plus 3. So u of n plus 3 now, n equal to minus 3 to infinity, u of n plus 3. Here it is minus 2, so plus 2, 2 to infinity u of n minus 2. Here it is minus 7, so 7 into infinity. So from 7 to infinity, the value will be 1. Here 2 to infinity, the value will be 1. Minus 3 to infinity, the value will be 1. So what happens from n 7 to infinity? The 7 to infinity, the value will be minus 2. So 2 into minus 2 into 1. So it will be minus 2. So here also from 7 to infinity, the value is 1. 7 to infinity, value is 1. So 1 plus 1 is 2. 2 minus 2 will be 0. So from 7 to infinity, the value will become 0. So before 7 to infinity, you have some value. So before to 7, now before 7 is 6. So minus 3 to 6. So what is minus 3 to 6 value? How many values you have? Minus 3, minus 2, minus 1, 0, 4. Then plus 6. So 10 values. Then 2 to 6. So 2 to 6 is 5 values, so totally 15. So summation n equal to minus infinity plus infinity, h of n is equal to 15. So it is finite. So since it is finite, it is said to be your stable. So the option is going to be A, stable. But thank you students. For more videos, subscribe the channel here. Bye.